Okay, now I'll show you how to generate depth map using depth editing v2. You see this example, original input image, RGB by the way, and this is generated depth mapped. You see this map contains relative values because depth editing v2 does not predict real world distance. It predicts relative depth, meaning which pixels are closer or farther compared to each other, just like in this example. You see there's 2%, and you see the relative depth value is around 350. And for example, this ground region values are around 600, and this top left values are close to 0. So these are all relative values compared to each other. If value is like higher, it means that objects are closer to the camera or fixed point, whatever you call it. And here there's one more example. You see there's two objects, and you see again you can see this rocks, for example, values are around 150, and this two object 350. And let's look at closer, for example, this bottom right, values are closer to 500. So these are all relative values. I will share link to this article in comment section. You can read it. I explained how this model works and how training is done. If you're interested, you can read this. But now I will directly show you how to create a proper environment for running models and how to run models. I will directly start with installation. You need to clone this depth editing v2 repository. Let me show you this. Okay, there's pre-trained models, installation guide. I copied directly from here. And I cloned this repository to here. You see here depth editing v2. So after that, there are a few libraries. You see here PyTorch, OpenCV, and other ones like matplotlib. So there's one important point. You need to, if you want to run your models faster, you need to create GPU supported PyTorch environment. You can follow this article for that. And if you decide to create GPU supported PyTorch environment, first you need to do that, and after that, you need to delete this toolline and install other libraries. But if you want to follow default installation, you can directly follow these 3 steps alone and directly install these libraries. You don't have to deal with like GPU supported PyTorch environment, it's up to you. After you created your environment, you need to download pre-trained model. You can click this link, same with this GitHub repository link. And there's 4 models, but 3 of them are available at the time. So I will stick with this large model, but you can use any model, it's up to you. So if you click like this, it will start to download. I think large model is around 1 GB, this small one is around 100 MB. So I will stick with this large one. And I download the model and copy it to, I think here, yes, checkpoints folder. You see here, oops. Yeah, you see here, large model, this one. I will use this. And yes, we can start. I will create new notebook inside this folder. Let's name it YouTube. By the way, I created my environment. You see here, depth editing env. Let me show you if this environment is GPU supported. Import PyTorch, prints. What I am doing, oops, my bad, sorry. Torch.CUDA is available. Yeah, it's true. So this means that this environment is GPU supported. Okay, first we need to import few libraries. Okay, CUDA is available and this is my PyTorch version. After that, we will load our model. You can delete this dictionary, by the way, because here you see this is the path to the model, and you can change this if you are using small model, for example with S. It's up to you. I will use large model. So you see here we are creating instance of this depth editing v2 class, and if you want to see how this class is implemented, you can go this depth editing v2 folder. After that you can go this file. Let me show you. Yeah, you see the class here, constructor, and you can see the methods. If you are interested, you can check the source code. So here we are moving model to GPU, and we set model to evaluation mode because we are not going to train anything. We will do inference. That's why we set it to evaluation mode. So this might take some time. Okay, perfect. Now it's time for inference. So under this assets folder, I have some images, for example, this one. So we basically read image and we are computing depth map using this infer_image method. You can see this method from here, same file. What was the name? Let me search for this. Yes, here. You see here. Okay, depth map is generated. You see this is same with this image resolution because for each pixel there is one value and this is relative depth value. You see the value range, mean value and standard deviation. So we can directly visualize this depth map, and next step is I think that yes, one. Yeah, you see these are relative depth values as I explained in the beginning. The higher the value, closer the region. So yeah, let me show you one more example. I have any test image, I'm not sure. But there's, yes, examples. I can use these files. For example, this one. Let me copy the paths. Here. So if you're not using GPU, this will take more time. Yeah, perfect. You see this car is closer to the fixed point, so you see here 800 value is higher. By the way, you don't have to, like, you can directly use this Python scripts for creating depth maps. For example, for video you can use this, and for image you can directly use this one. Let me quickly show you that as well. So you need to open new terminal, activate your environments. I name it as depth, I think anything, and did I miss something? I'm not sure. Depth, anything, and yes, I missed this conda. So let me clear this. And you can, as I said before, you can directly use this one, this file, Python, py. Okay, so there are a few arguments here, image paths. So let me, for example, we can use this image again, assets, and in that JPEG. What other things? These are default with large. Yeah, I'll use this one, but I can write it because you might use different models, so you can see with large. Okay, where is the output path by the way? Yeah, out directory. Okay, under this folder, I think. Yes. Let me run this. No such file. Oh, I have to be inside this repository. So let me go there. Okay, let me clear and run. So output will be generated under this folder. 3 steps. Okay, no problem. Progress. Yes, perfect. Let me show you the result. No, not this one, I think. Yeah, this one, yes. You see? Perfect. Yeah, let me do one more. For example, let me do this one. Okay, perfect. It started. Yeah, depending on your GPU, this might take more or less time. Okay, where's the result? Here. Yeah, perfect. This one is better actually. You see the colors. Yeah, if you want to process videos, you can use this file, run video. And I think that's it for this video. Thanks for watching. See you soon.